Okay, so it's just a quick video on IP addressing, just to give you a little more information on it. Basically, what we do when we want to communicate with networks, we're going to have a series of computers, and the computers are going to be connected together with something. So it could be, we call those computers hosts. So there could be any number of computers that are connected together. Um, I have a little diagram here. It shows the little cubes standing in for the computers. So could be one, could be two, could be 10, could be 10,000. Whatever we have, it's represented by a number in. We don't know how many there are. Right? In real life, we would know because they would translate to physical things. But essentially, what I have to do, because I have to communicate back and forth between these computers, is I have to give them a unique number so that they can communicate with each other. So what we've come up with is the IP addressing scheme, and this is just a way to uniquely identify computers. Now, at a low level, these numbers look like series of zeros and ones. It's a binary. So in this case, I have these zeros and ones split up into four, and if I put them into series of 8 values, right? Eight. These are called bits. It actually makes 1 byte. So this particular number is a stream of bits that is 4 bytes long. So we actually can translate that into a decimal number so that makes it easier for us humans to understand it. And that's all we're doing here is we're taking this binary code, we're translating it into a decimal number that makes it easier to understand. And we are putting it in this format with dots in between the numbers. Now, these numbers are called octets. So, and it's an octet because it consists of 8 bits. 8 is octal. Okay, so that's if you think about it, an octagon, a stop sign, it had 8 sides. So it's not a hexagon, which has 6 sides. Square has 4 sides. Octagon has 8 bits. In a byte is an octal value. Okay, so we have taken this and we have taken an IP address. Now this is what I would call an IP address. It is just a series of bits that designate an address for a host. Because each host on a network has to have a unique IP address. But that doesn't mean that each host has to have a unique IP address off the network, because there could be multiple uses of that. It's not globally unique. The MAC address on the network interface is globally unique, but this is not. This is another way to identify that device on a network. We do it with an IP address. So we have addresses in the network, and there's 2 different kinds of addresses. We have an IP address that's called a network boundary, and that IP address is not a valid IP address for routing. So it would end in a 0 in this case. I usually put a slash notation on the end to signify the boundaries of that network, how big it is. In this case, that /24 corresponds to 8, 16, 24 bits that denote the network, and then the last 8 bits denote the host. When we take that notation, the /24, we subtract it from the 32 bits that make up the IP address, what we get is 8. So the last 8 bits are reserved for hosts. In this particular network that I've defined, there can be 256 possible IP addresses, one of those, which is the 0, is the network boundary. So that means that there can only be 255 addresses here. One of those is the broadcast address. That's 255. And that's the function of it. Okay, we talked about broadcast in the last course. Broadcast addresses are used to send packets out. And then so the number of hosts I have available, actually assignable host addresses, 254 in the subnet. One of those hosts becomes the gateway. The gateway is just a way to get the data off the network. Okay, that's what it's for. So in my subnet, my little subnet I've created here, I'm going to have a couple things. I'm going to have a network identifier. I'm going to have a gateway address. I'm going to have any number of host addresses. And I'm going to have a broadcast address. These are the 4 things that are there in the network. The broadcast address does not always have to end in 250. Does not always have to be 255. It will not always be 255. It is the last address in the network defined by the network boundary. So I do this because it's simple. This is my network boundary. This is my broadcast. It is the last possible IP address in the network. 255. Okay. That's the last, and because it's an IP address that is just designates one IP, I'm going to put a /32 there. That is optional. I don't have to have it. Okay. So 255 is the last usable address in the boundary. There is no 256. We start counting with 0, and we continue to count. When we get to 255, we have reached the 256th value there. I can't go anymore. My 8 bits are used up. So at that point, when I look at the 8 bits that are there, they're going to be all ones. 1, 1, 1, 1, 1. All ones here. Okay. So that's this definition of the network. Is the first one is the network boundary, which is the one we see here. Then we have the broadcast address. So those are easy. Those are the first 2 things we can define in the network. We always know first and the last, right? So now we fill in the rest. So I have one host that's going to act as the gateway address. I can assign it whatever address I want to. It doesn't matter. Conventionally, I either use the first address that's assignable to a host or the last address that's assignable to a host. In this case, the convention is I'm going to do 1.1. That means that available host addresses for the network are 2 to 254. I'm going to say available host after the gateway. So we know that the true hosts on this network are from 1 to 254. Because the gateway is just any other host that happens to be able to forward traffic outside of the network, right? That's the special nature of the gateway. All right, that's it for this video. And this is basically the way we, the one other thing I want to tell you about is just the way we number hosts. We just assign addresses in whatever order you want. You just start giving them out addresses. No host can have the same IP address. They all have their own. That's why they're unique within that particular network. And so you just give them out. Give them out to whatever computer device that needs one, until you either run out of addresses or you run out of devices. All right, thanks.